Hi, this is Schwartz from MasterMathMentor.com. This is video BC26a. The topic is manipulation of series, and it covers the BC manual pages 125 through 127. Suppose we have a power series f of x, which is summation n equals 0 to infinity of a sub n quantity x minus c raised to the n. We know we can expand this as a sub 0 plus a sub 1 quantity x minus c plus a sub 2 quantity x minus c squared plus a sub 3 quantity x minus c cubed. And that has a radius of convergence r and an interval of convergence c minus r to c plus r. With that, it follows that if we take the derivative of this series, f prime of x, that will be summation n equals 1 to infinity of n a to the n times the quantity x minus c raised to the n minus 1. We are simply taking the derivative of the general term. We say 1 to infinity because the constant term will drop out. So this will be a sub 1 plus 2a sub 2 quantity x minus c plus 3a sub 3 quantity x minus c quantity squared plus dot dot dot. We could also take the integral of our power series f of x dx, and this will be c plus summation n equals 0 to infinity of a sub n times x minus c raised to the n plus 1 over n plus 1, just using the power rule on the general term. And this becomes c plus a0 times quantity x minus c plus a sub 1 over 2 quantity x minus c quantity squared plus a sub 2 over 3 x minus c quantity cubed plus dot dot dot. The radius of convergence r will not change from the original series, but the convergence at the endpoints could change, and you'll have to check that out. For number 1, we are given the power series f of x equals summation 0 to infinity of x over 2 raised to the n. We would like to expand the series, finding the radius of convergence and the interval of convergence. Then we will take the derivative of the series and again find the interval of convergence, and finally take the integral of the series, finding the interval of convergence. When we expand our series, we get 1 plus x over 2 plus x squared over 4 plus x cubed over 8 plus x to the 4th over 16 plus dot dot dot. This is geometric, x over 2 raised to the n, and the absolute value of x over 2 has to be less than 1 for convergence, meaning that x must be between negative 2 and 2. So the radius of convergence is 2. If x equals negative 2, our series is 1 minus 1 plus 1 minus 1, which fails the nth term test and is divergent. If x is equal to 2, then our series is 1 plus 1 plus 1 plus 1 plus dot dot dot, and again that fails the nth term test and is divergent. So our interval of series is the interval negative 2 to 2, and it is the open interval. So let's look at f prime of x, which will be summation n equals 1 to infinity of n over 2 times x over 2 raised to the n minus 1. Expanding this is 1/2 plus 2x over 4 plus 3x squared over 8 plus 4x to the 3rd over 16 plus dot dot dot. When x is equal to negative 2, our series is summation n equals 1 to infinity of n over 2 times negative 1 raised to the n minus 1. And when expanded, this is 1/2 minus 2 over 2 plus 3 over 2 minus 4 over 2, and this fails the nth term test and therefore is divergent. The same is true when x is equal to 2. our series becomes summation n equals 1 to infinity of n over 2 times 1 to the n minus 1, and all our terms are positive. 1/2 plus 2 over 2 plus 3 over 2 plus 4 over 2 plus ... And again, this fails the nth term test and is divergent. So like the original series, the interval of convergence is still the open interval, -2 to 2. To integrate f of x dx, we integrate the series general term, and using u substitution, we get summation n equals 0 to infinity of 2 times x over 2 raised to the n plus 1, all over n plus 1. And this is equal to c plus x squared over 4 plus x cubed over 12 plus x to the 4th over 32 plus x to the 5th over 80 plus ... When x is equal to -2, our summation will be 2 times -1 raised to the n plus 1 over n plus 1, which will be c minus 2 plus 1 minus 2/3 plus 2/4 minus 2/5. And this will be an alternating series with the terms getting smaller, so it is convergent. But when x is equal to 2, our series is simply 2 over n plus 1, which is c plus 2 plus 1 plus 2/3 plus 2/4 plus 2/5. And that is a harmonic series which is divergent. So the interval of convergence is the inclusive -2 and the open 2. There are basic functions that are used very frequently and can be represented by Taylor series. While they can be generated by the techniques learned, that is time-consuming, and students should memorize the first 4 because they come up so often, and recognize the other ones. First, our 2 trig expressions. Sine of x is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus ... And the general term is -1 to the n x raised to the 2n plus 1 over 2n plus 1 factorial. The interval of convergence is -infinity to infinity. Cosine of x is similar, but it uses the even powers. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus ... And the general term is -1 to the n x raised to the 2n over 2n factorial. Again, the interval of convergence is -infinity to infinity. And our exponential e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus ... plus x to the n over n factorial plus ... And again, the interval of convergence of this one is -infinity to infinity. We have 2 fractions. The first is 1 plus 1 over x, and this can be written as 1 minus x plus x squared minus x cubed plus x fourth minus ... and the general term is -1 to the n x to the n. The interval of convergence for this series is the open interval -1 to 1. And 1 over x, and this can be written as 1 minus x minus 1 plus x minus 1 quantity squared minus x minus 1 quantity cubed plus x minus 1 raised to the 4th minus ... and the general term for this one is -1 to the n times x minus 1 quantity raised to the n. And the interval of convergence for this one is 0 to 2. We will see in a few minutes how these last 2 are related. Finally, our transcendental functions. The natural log of x can be expressed by It's series x minus 1 minus x minus 1 squared over 2 plus x minus 1 quantity cubed over 3 minus x minus 1 raised to the 4th over 4. This can be written as the general term negative 1 raised to the n minus 1 times x minus 1 raised to the n over n. And the interval of convergence is the interval 0 to 2, where 0 is open and 2 is closed. And finally, the inverse tangent of x can be written as x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7th plus dot dot dot. The general term here is negative 1 to the n, x raised to the 2n plus 1 over 2n plus 1. And the interval of convergence here is the closed interval negative 1 to 1. The function y equals e to the x is an interesting one because it is the only function other than y equals 0 whose derivative is equal to itself. Let's use Taylor polynomials to show that derivative of e to the x is e to the x. We take the derivative with respect to x of e to the x, which is the derivative with respect to x of 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot 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 plus x to the n over n factorial plus x to the n plus 1 over n plus 1 factorial plus dot dot dot. When we do that, we get 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus nx to the n plus minus 1 over n factorial plus n plus 1 x to the n over n plus 1 factorial plus dot dot dot. So our terms are 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. And when we look at n over n factorial, we get a cancellation of the n's. So we have x to the n minus 1 over n minus 1 factorial. When we look at n plus 1 over n plus 1 factorial, the n plus 1's cancel and we get x to the n over n factorial plus dot dot dot. And of course that is equal to e to the x. 2b asks us to prove if capital F of x equals the integral of e to the x dx with capital F of 0 equaling 1, then capital F of x has to equal e to the x. So f of x is equal to the integral of e to the x dx, and using our definition above of e to the x, we get x plus x squared over 2 plus x cubed over 3 times 2 factorial plus x to the 4th over 4 times 3 factorial plus dot 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 plus x to the n over n times n minus 1 factorial plus x to the n plus 1 over n plus 1 times n factorial plus dot 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 plus c. So that simplifies to x plus x squared over 2 plus x cubed over 3 factorial, as 3 times 2 factorial is 3 factorial, plus x to the 4th over 4 factorial plus dot 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 plus x to the n over n factorial plus x to the n plus 1 over n plus 1 factorial plus dot 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 plus c. When we plug in 0, f of 0 is equal to 0 plus c, which is equal to 1, and therefore c is equal to 1. And therefore f of x is equal to 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot 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 plus x to the n over n factorial plus dot dot dot. And of course that is still equal to e to the x. We have the expression sine of 1/2 x, and we would like to create a Taylor series for this expression centered at 0. We'd like to do it in two ways. First, in the traditional way of creating a Taylor series, and then by using a parent function of the type that we just showed in order to easily manipulate it to get sine of 1/2 x. So f of x equals sine of 1/2 x and f of 0 equals 0. Our first derivative is 1/2 cosine of 1/2 x, and f prime of 0 is equal to 1/2. The second derivative is negative 1/4 sine of 1/2 x, and the second derivative at 0 is 0, while the third derivative is negative 1/8 cosine of 1/2 x, and the third derivative of 0 is negative 1/8. The fourth derivative is 1/16 sine of 1/2 x, and the fourth derivative at 0 is 0. And the fifth derivative is 1/32 cosine of 1/2 x, and the fifth derivative of 0 is 1/32. So we can say that sine of 1/2 x is equal to 1/2 x minus x cubed over 8 times 3 factorial plus x to the fifth over 32 times 5 factorial minus ... In the previous method, the derivatives were not difficult, so the procedure did not take up a lot of space and time, although with more difficult expressions it can. This method is far easier. Since this is a sine function, we will define our parent function as f of x equals sine of x, which we know is x minus x cubed over 3 factorial, plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial, plus ... So if that is f of x, then sine of 1/2 x can be written as f of x over 2. And what we then do is replace in our parent function every x with an x over 2. So we end up getting x over 2 minus x over 2 quantity cubed over 3 factorial plus x over 2 quantity to the fifth over 5 factorial minus x over 2 quantity to the seventh over 7 factorial plus ... And we end up with the same expression that we got on the previous method, x over 2 minus x cubed over 2 to the third times 3 factorial plus x to the fifth over 2 to the fifth times 5 factorial minus x to the seventh over 2 to the seventh times 7 factorial, and we can now write the general term as negative 1 to the n times 2 to the n plus over 2 to the n plus 1 times 2n plus 1 factorial. In problems 4 through 6, you are to choose a parent series in order to generate a Taylor series centered at 0 for the given functions. Include in your answer the general term. Number 4 reads f of x equals cosine of the square root of 2x. We'll define our parent function g of x to be cosine of x, which is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the sixth over 6 factorial plus ... So cosine of the square root of 2x is simply g of the square root of 2x, which is 1 minus the square root of 2x squared over 2 factorial plus the square root of 2x to the fourth over 4 factorial minus the square root of 2x to the sixth over 6 factorial plus ... So we can say that this cosine of the square root of 2x is 1 minus 2x over 2 plus 4x squared over 4 factorial minus 8x to the third over 6 factorial, and therefore our general term is negative 1 to the n times 2x quantity to the n over 2n factorial. Number 5, f of x is equal to sine of x cubed. Our parent function is g of x equals sine of x, which is x minus x cubed over 3 factorial plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial plus ... So the sine of x cubed is simply g of x cubed, which is x cubed minus x cubed cubed over 3 factorial plus x cubed to the 5th over 5 factorial minus x cubed to the 7th over 7 factorial plus dot dot dot. So the sign of x cubed is x cubed minus x to the 9th over 3 factorial plus x to the 15th over 5 factorial minus x to the 21st over 7 factorial plus dot dot dot. Our general term is negative 1 to the n x raised to the 3 times quantity 2n plus 1 over quantity 2n plus 1 factorial. On numbers 4 and 5, think about how difficult this would be if we were forced to use our definition for our Taylor series and go through it derivative by derivative. For instance, on number 5, the first derivative of sine of x cubed would be cosine of x cubed times 3x squared. To take the derivative of that, we would need a product rule. And as we take more and more derivatives, our product will have more and more factors, making it very difficult to take the derivative. And even if we could, you notice by our answer that many of the terms are missing, meaning that their coefficients are 0. So to get this type of accuracy would take us a great deal of time. The method we chose here using a parent function makes the problem very easy to do. 6 is f of x equals e to the negative x. Our parent function will be g of x equals e to the x, which is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot dot dot. So e to the negative x is simply g of negative x, which is 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot dot dot. And our general term will be negative 1 to the n times x to the n over n factorial. For problems 7 through 9, you are again asked to generate a Taylor series centered at 0, along with the general term. It should be clear, based upon the complexity of the functions, that you're not going to want to use the standard procedure to generate this Taylor polynomial, as taking derivatives will get very difficult after a couple. You are to use the method of choosing the parent function and then generating the series from there. Number 7 reads f of x equals x squared e to the x. Our parent function, g of x, will of course be e to the x, which is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot dot dot. So x squared e to the x is simply x squared g of x, which is x squared plus x cubed plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial plus x to the 6th over 4 factorial plus dot dot dot. And our general term will be x raised to the n plus 2 over n factorial. Number 8 reads f of x equals the inverse tangent of x over x. Our parent function, g of x, will be the inverse tangent of x, which is x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus dot dot dot. So the inverse tangent of x over x is simply g of x over x, which is 1 minus x squared over 3 plus x to the 4th over 5 minus x to the 6th over 7 plus dot 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 plus negative 1 raised to the n, x to the 2n over 2n plus 1. 9 reads f of x equals x cosine of x to the 3 halves. Our parent function is g of x, which is cosine of x, and that is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot dot dot. So x cosine of x to the 3 halves is x g of 3 halves, which is x times 1 minus x cubed over 2 factorial plus x to the 6th over 4 factorial minus dot, dot, dot. So x cosine of x to the 3 halves is simply x minus x to the 4th over 2 factorial plus x to the 7th over 4 factorial minus dot, dot, dot. And our general term is negative 1 to the n x to the 3n plus 1 over 2n quantity factorial. In the second half of this video, we will look at the function 1 over 1 plus x and see that it can be written as 1 minus x plus x squared minus x cubed plus x to the 4th plus dot, dot, dot plus negative 1 to the nth x to the nth, and see how we can use this function to basically eliminate the need for division on your calculators.